Hello everyone, today I'm going to introduce you a way to teach computer to play tic-tac-toe. The first method we considered is a simple way. We just record every possibility, and while an AI is going to find what step it's going to take, it just search for the table. So for the situations like this, for example, the next step, the computer is definitely going to choose this position because it will stop the player from winning the game. And also for situations like this one, yes, and the computer will choose this position to win the game. Basically, this is how the lookup table method working. Problem is it will take up a lot of storage. On the other hand, this AI was more like giving out reaction based on the memory, not emphasize much on the progress of thinking. And this point between the initial way of us that want to build some kind of artificial intelligence. Now let's adopt another way to play tic-tac-toe. This time we build a tree to describe in which step the game is going on. We assume the first round is the player's round, so he can play arbitrary any position on the playboard. Like there should be 9 possibilities, right? So we denote player's round with blue circles, and the next should be the computer's round. Keep this going down. And we'll get at some stage that the game will come to an end. Either it will be a tie and we denote it with 0, or the player wins and we return the results with -1, and if the computer wins, we return +1. So the purpose of the AI is to have as large results as possible. For example, if we can ensure we can get +1, then this branch is definitely what we want. But the problem is we need to assume the player is also doing their best. So for computer rounds, we need to return the max results from all its children. And for player rounds, we assume he also played the best role. So this time we need to return the minimum results from its children. So by this method, we build this like min and max tree and decide which result we can get. And this is more like a recursive way people thinking. This time, we see we build a more intelligent agent than lookup table method. We introduce the concept of winning or lose and represents in logic. For example, winning is +1, losing is -1, which is the only readable language for computers so far. And secondly, we let it think from both aspects. Not only just standing on the AI aspects, we also consider the competitor, the player, what they're going to work. Third, we make it more easier for extension. For example, we can easily change it into chess once we set up the rules in the definition of winning or lose, and the key mind is all the same. To conclusion, for the lookup table, we like competing with a big computer because it will have large space for storage. And for the second method, game tree, if we are facing not only the tic-tac-toe but a rather more complex game, it may take a lot of time to do this algorithm. So we need to keep a balance between storage complexity and time complexity. Last but not the least, we're going to ask the question, what is artificial intelligence? In this game, we develop 2 methods to win the game. But in the human world, we're not only to seeking the truth. Sometimes we need to take into humans' emotion as well. For example, if we going to play tic-tac-toe with a little children and we always win the game, the child will lose his interest. And this is not what we want. So It's very important to define the ultimate target for artificial intelligence, whether it's working for human, making them look like human, like friends to us, or use artificial intelligence to find the truth. Thank you very much.